Okay, let's now take a look at shift registers. We've done our memory elements and we've been introduced to the whole cluster of flip-flops. Now with the shift registers, we are going to look at the left shift, we're going to look at the right shift, we're going to consider the OR circuit, so we can do left or right. All right, so I will say left or right. Probably let me move that. Let me say left or right. Okay, we have to understand these concepts first. All right, so now what I'm going to do is starting with the left shift. What is the left shift register? First of all, shift registers, as when we discuss the D flip-flop, not the D type flip-flop, the delay type, the D type flip-flop, okay, we said we use this D type flip-flops we use them as for shift registers, okay. Otherwise we can use others configured as such, okay. Otherwise, other configured as a D type, all right, configured as D type, all right, as such. We either use D type flip-flops or any other one that is configured as what, as such. We've shown you how other flip-flops, the JK for instance, how it can be used as a what, as a D type. We've shown you how the SR can be used as what, as a D type. So with D type, let's say we want to shift left. Remember that our I'm trying to do straight lines here. That wasn't bad. Our shift registers, let's say this is the shift register. There is two options here, okay. On the shift register, either remember that we are going to have what, the bits, the Q bits, Q1, Q2, Q what, Q4, blah 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 blah, up to what, up to the highest order that we have. Alright, I'll call it 2n just to say it's going to be what. Now let me not say 2n, let me rather say Qn, but it's going to be some power of 2, right? So depending on the number of what, let me rather say, no, I can't say 2 to the power of n, can I? Let me just say 2n, right? Let me just say 2n. But what we know here is that this is going to be what? This is going to be the powers of 2, all right? So when we have a left shift register, okay, info comes in, or data comes in through the right, okay, and with each flip-flop, with each clock pulse, okay, passes to the left, okay. All right, one bit at a time, obviously, one bit at a time. All right, we'll see what we mean by this later, okay. So what we mean here is with the left shift, information comes this way, comes in this way, and comes out that way. In fact, it moves that way, and depending on the number of clock pulse, it will end up coming on the what, on the left side. All right, that is the left shift. All right, with the other one, now we'll say Q to the N, Q to the N minus 1. No, not really N minus 1. That will be N divided by 2. But anyway, you know that that power is going to be 2 less. We know that it goes down by factors of 2, right? Let me not say q to the power n minus 2 divided by 2, because I don't want to get too technical with this. I don't want to. Let me avoid just being way too technical, because we know that with the powers of 2 here, you know that they are going down by a factor of 2, right? But so it would have been q n what n over 2. But let's just keep the structure we had there. Q4, just to remind people, that is what q2 is powers of what this is 2 to the power of 0, 2 to the power of 1, to the power of 2, endlessly up to what, up to the biggest bit. Okay, so with the right shift is the opposite, obviously. Info comes in the, oh, I should have said then info comes in the right. I should have also mentioned there, probably, let me move this for those who take notes. Let me move this and rather say, right, control Z. Let me just delete this and come here and say it comes in through the what, through the LSD, right, least significant digit. All right, and with each bit pass to the left 1 bit at a time, ne? So it's moving towards the what, it's moving towards the MSD. All right, so this is towards the, I want to really make sure that people understand, so I'm gonna take my time with this. So the data is moving towards what, 1 bit at a time. The data is moving towards, sliding towards the MSD. All right, so data comes in through the what, through the LSD. There's no need for that, but it is going to, the bits are going to move towards the what. If you keep shifting, obviously the bits are going to get lost. All right, so the right shift, the info comes in through the left, which is the MSD, through left MSD. Okay, and glides same way, 1 period at a time, ne? Glides towards the right. Okay, the right, and that will be the what, the LSD, right? But obviously if you pass further, it will get lost on the what, on oh, what am I saying? Yeah, to the right. Yeah, to get lost on the what, on the right side, to fall off on the right side. All right, so the info comes in through the highest, through the most significant digit, and it is sent to the what, in the direction of the what, of the LSD. So that is the difference between the what, that is the difference between the what, the left shift and the right shift. All right, right shift, that is the primary difference between the two. All right, so I think I need to probably pause there. I'll come then and do what, and do the diagrams. Or I need that to be my initial session, so that people at least get what's called this, get a hang of what we mean by shift left or shift right. All right, I'll come in now and start doing the actual diagrams.